3-point charges. Here's a new example for us to work on. Charge Q1 is positive 30.0 coulombs of charge, located here at this point. A distance of 4.00 kilometers to the right of it is charge Q2. Charge Q2 is positive 20.0 coulombs. From charge Q2, go 2 additional kilometers to the right to get to charge Q3. Charge Q3 has a value of positive 50 coulombs of charge. Solve for the net force acting on Q1. All right, so to summarize the past couple of minutes, I've just calculated as a check on the students. So one group of students got an answer I agree with. The other two groups have answers that I dispute. And as part of resolving all this, I've just calculated what is the force of repulsion between charges 1 and 2. I get 337,000 newtons. The force of repulsion between charges Q1 and Q3, I get 375 kilonewtons. The force of repulsion between charges 2 and charges 3, I get 2,250,000 newtons. Now, what do I do with these three sets of numbers? It depends on my point of view. From the point of view of Q1, Q2 is pushing me to the left with 337 kilonewtons. Q3 is also pushing me to the left with a force of 375 kilonewtons. So if I want to calculate the net force on Q1, I would add 337 plus 375 means the net force to the left is 712,000 newtons, pushing to the left. That, I concur, is the net force on Q1. Turning my attention to Q2. The force on Q2 is Q1, which is 337,000 newtons, pushing it to the right. And I'm not doing this to any meaningful scale. So here's 337,000 newtons pushing Q2 to the right. Q3 is a much stronger force pushing it to the left. So Q3, again, not really to scale, 2,250,000 newtons pushing it away from it, pushing it to the left. So to find the net force, one pushing left, the other pushing to the right, I really need to take the difference between them. 2,250 minus 337 means the net force on Q2, I get 1,910 kilonewtons. In other words, 1,910,000 newtons pushing left. That is the net force for Q2. So I dispute the answers that you students agreed to. Now I go over to Q3, and I'm going to draw it over here, so I'm not to scale on this either. For Q3, I have charge 1 pushing Q3 to the right with 337 kilonewtons. I also have charge 2 pushing Q3 to the right with 2,000,000 250 kilonewtons. I said that wrong. 2,250,000 newtons. To find the net force on Q3, I would add these two forces together because in this case, they are going the same direction. So 337 plus 2,250 means I have 2,590,000 newtons pushing to the right. Now, that's pretty close to the answers you students put in terms of the numerator, 2.62 compared to 2.59. This is 10 times 10 to the 6th power. This is a million times greater than that when you say to the 12th power. You also said it was to the left when really it is pushing it to the right. So no, you have not yet mastered doing 3-point charges in a row.